I need to present the photos to my client next week, but I still have no idea what to take. What should I do? Oh, that's interesting. I might find some inspiration if I go inside. Okay, let's go in and check it out. Oh, there are so many polygons. Squares, rectangles, triangles, parallelograms, and trapeziums. Wow, there are also prisms and cylinders. Let's take a photo first. To calculate the area of the hexagon like this, we can use dissection method. The hexagon can be cut into two trapeziums. If the height of each trapezium is 1 divided by 2, that is 0.5 meter, then the area of each trapezium is 0.6 plus 1.2 times 0.5 and then divided by 2, that is 0.45. In other words, the area of each trapezium is 0.45 square meters, and the sum of the areas of the two trapeziums equals 0.9 square meters. Therefore, the area of the hexagon is 0.9 square meters. This place is so special. The photos taken here will definitely impress my clients. To calculate the area of this figure, we can cut it into 4 rectangles. Besides using the dissection method, we can also use the filling up method to calculate the area of the figure. Fill it up with an identical figure to turn it into a rectangle. Now, we'll first calculate the area of the rectangle and then divide it by 2. If the frame is 60 centimeters long and 45 centimeters wide, a photo 45 centimeters long and 30 centimeters wide can be put inside. We can use the areas of 2 simple figures to calculate the area of the frame. In other words, the area of the outer rectangle minus the area of the inner rectangle. Using this method, the area of the frame comes to 1,350 square centimeters. If we cut the circle into 8 equal parts and then rearrange them, the following figure will be formed. The lateral side of the figure is the radius of the circle. The top of the figure is composed of a set of arcs. The base of the figure is also composed of a set of arcs. If the 2 sets of arcs are combined together, the length of the 2 sets of arcs equals the circumference of the circle. and the circumference equals 2 times pi times the radius. If we take the radius as r, the circumference equals 2 times pi times r. That means the length of the two sets of arcs is equal to 2 times pi times r. The length of the base must be half of the circumference. In other words, pi times r. Hence, the length of the lateral side is r, and the length of the base equals pi times r. We may also try to cut the circle into 16 equal parts to get the following figure. The length of the lateral side of the figure is still r, and the length of the base of the figure is still pi times r. However, the lines of the top and the base are not as curved as before. If we further cut the circle into 32 equal parts, the length of the lateral side of the figure is still r, and the length of the base of the figure remains pi times r. But now, the base of the figure looks more like a straight line. When a circle is cut into many equal parts, the resulting figure looks more like a rectangle, with the width of the rectangle being r and its length pi times r. The area of the rectangle equals its length times its width, that is, r times pi times r, or simply pi times r squared. Therefore, the area of the circle equals pi times r squared. These are prisms and cylinders. The base and the top of the prism are identical and parallel to each other. If we take a plane parallel to the base and the top that cuts across the prism at any point, the cross-section will be identical to and have the same area as the top and the base. In other words, the prism is a solid with a uniform cross-section. A prism with a rectangular top and base is called a rectangular prism, and a prism with a circular top and base is called a cylinder. Their volumes are calculated in this way. For example, the volume of the rectangular prism equals length times width times height. As the length times the width equals the base area, the volume of the rectangular prism can be calculated by base area times height. When the length, width, and height are the same, the prism becomes a cube. Therefore, the volume of the cube equals the cube of the length of one of its sides. The two buildings are prisms also. This building has a uniform triangular cross-section, so it's a prism. It's called a triangular prism. This building has a uniform hexagonal cross-section and is called a hexagonal prism. Their volumes can be calculated in this way. As a polygon can be divided into triangles, we can find out the volume of the hexagonal prism based on volume of the triangular prisms. For example, the hexagonal prism can be divided into 4 separate triangular prisms. As the volume of triangular prism equals the triangular base area times height, the volume of hexagonal prism equals the sum of volumes of triangular prisms. As the height of these triangular prisms are the same, we first add up the areas of the 4 triangular bases and then multiply it by the height. This is the same as the base area of the hexagonal prism times its height. All these equations can be used to calculate the volume of a hexagonal prism. In fact, prisms and cylinders have a kind of subtle relationship. They are both solids with uniform cross-sections. If we change the hexagonal prism into a prism with a 12-sided polygonal base, like this, and then a 24-sided polygonal base, and so on, a hexagonal prism gets closer and closer to looking like a cylinder. We understand that the volume of the prism equals the base area times height. When the volume of the prism approaches the volume of the cylinder, the base area of the prism gets closer to the area of the circle. Therefore, the volume of the cylinder equals the circular base area times height. The base area is the area of a circle, that is pi times radius squared. So the volume of the cylinder equals pi times radius squared times height. If r is the radius and h is the height, the volume of the cylinder equals pi times r squared times h. The cross-sections of an egg are not equal. Some are larger and some are smaller. So an egg is neither a prism nor a cylinder. How do you calculate the volume of this pile of cuboids? The solid is formed by many cuboids. Therefore, the volume of the solid equals the sum of the volumes of cuboids. As the volume of each cuboid equals the base area times height, and all cuboids have the same height, we can first add up the base areas of all the cuboids and then times it by the height. In other words, the sum of the base areas times height. Hence, the volume of the solid can be calculated in this way. If the solid is further divided into smaller cuboids, it gets close to looking like a triangular prism. Its base is similar to a triangle. In other words, the total sum of the base areas is about the same as the area of the triangle, and its volume is about the same as the volume of the triangular prism. Therefore, the volume equals the area of the triangle times height, that is, base area times height. The oranges are peeled off. When the skin of the orange is spread out flat, they all have different sizes. The size of the skin represents the size of the orange. Therefore, when the skin of the orange is spread out, it forms a net representing the surface of the orange. Just like the nets of these prisms and cylinders, to find their total surface areas, we need to find the areas of their nets. This solid is a cuboid. The net of the cuboid represented here is made up of 6 rectangles. 2 rectangles are the 2 bases of the cuboid, and the other 4 rectangles are the lateral surfaces of the cuboid. Therefore, the surface area of the cuboid equals the total sum of the areas of the 6 rectangles. That is, the areas of the 2 bases and the area of the 4 lateral surfaces. If we take the length of the sides of the cuboid as A, B, and C respectively, the areas of the 2 bases are the same, making the total area A times B times 2, that is 2AB. The areas of these 2 lateral surfaces are the same, making the total area C times A times 2, that is 2CA. Lateral surfaces are also the same, making the total area B times C times 2, that is 2BC. Finally, we can find out the surface area of the cuboid using this approach. This is a hexagonal prism, and its net is like this. The 2 bases are hexagons. and the 6 lateral surfaces are rectangles. Therefore, the surface area of the hexagonal prism equals the areas of the 2 hexagonal bases and the areas of the 6 rectangular lateral surfaces. In other words, the sum of the base areas plus the sum of the lateral surface areas. The 2 bases of the cylinder are circles. Let r be the radius of the circle and h be the height of the cylinder. To find the surface area of the cylinder, we can cut the cylinder and lay it flat as shown in the figure. The curved surface of the cylinder gives a rectangle. Its length equals the circumference of the circular base, that is 2 times pi times r. If width equals height h, then the curved surface area of the cylinder equals 2 times pi times r times h. In other words, 2 pi rh. The 2 base areas of the cylinder equals twice pi times r squared. Therefore, the total surface area of the cylinder equals the areas of the 2 bases plus the curved surface area of the cylinder. The photos are okay. It should be enough. Now we understand how to calculate the surface area and volume of the prism and cylinder. How about you try to help the cameraman leave this place by solving the following question. This is an ice cube with sides of 10 centimeters each. After it is melted, it is frozen to form a cylindrical ice lolly with a radius of 7 centimeters. What is the height of the ice lolly? The base area of the ice lolly equals pi times 7 squared. If the height of the ice lolly is h centimeters, its volume equals pi times 49 times h. After the ice cube is melted, it is frozen again without changing in volume. The volume of the ice lolly equals the volume of the ice cube. The volume of the ice cube equals the length of its side multiplied by itself 3 times. In other words, 10 times 10 times 10, which equals 1000 cubic centimeters. Therefore, pi times 49 times h equals 1000. Using pi equals 22/7, the height of the ice lolly is about 6.5 centimeters after solving for h. Furthermore, we find that the surface area is reduced when the cube becomes the ice lolly. The base area of the cube equals 10 times 10, which gives 100 square centimeters. As the base area equals the lateral surface area, the total area of the cube equals 6 times the base area. In other words, 6 times 100, which equals 600 square centimeters. The surface area of the ice lolly equals the sum of the circular base areas plus the lateral surface area. That is 2 times pi times 7 squared plus 2 times pi times 7 times 6.5. After this calculation, the surface area of the ice lolly is about 594 square centimeters. Therefore, when the ice cube is turned into the ice lolly, the surface area is reduced by about 6 square centimeters.